Hi, Kirby. Welcome to the show.
Hi, Beth. Thanks for having me.
Happy Friday. You bet. You're at your alma mater, I see.
Yes, I'm at my alma mater, Johns Hopkins University, where I did my PhD. That was 6 years ago that I finished, but it's good to come
Congrats.
back. Thank you.
Does it feel like the campus is the same in the programs?
Yeah, a lot at Johns Hopkins is similar to when I was a student here, and particularly I'm in the Department of Earth and Planetary Sciences, and it's a really great department, particularly because it's just a very custom-tailored graduate program for the students. There's no hard requirements in terms of classes. You just talk with your graduate committee about what classes make sense for you to take, and
That's
it's a
awesome.
very collaborative research environment, and I was a very happy graduate student here.
That's amazing. So you're saying I could go to Johns Hopkins University?
Uh, Anyone can apply.
Well said. That's great. Oh my gosh. I can't wait to talk to you today. I'm so grateful we
Thank
got to
you.
meet in person at Yuri's night. So
Yes.
many questions. And whenever I'm trying to navigate the ideas and themes and topics that would you call yourself an astrogeologist?
Well, I'm a planetary geologist.
Oh,
Hmm.
cool.
Yeah.
Okay. When I think about that, I think about what kinds of questions kids, families, and everyday space enthusiasts might want to know. And my very first question is, and again, we didn't get to have any discussion prior, but
Right.
we're chasing water in the universe for a big reason. And we
Yes.
think that's where we can find life. So, can you walk us through why we're efforts for financial purposes and exploratory purposes is
Mhm.
towards water?
Sure. So let me back up a little bit first. So as a planetary geologist, my job is to explore the rocky and icy worlds in the solar system. Geology, of course, is the study of rocks and rocky landscapes, and it's not really astronomers who are studying the surfaces of planets. Geologists study the surface of Earth, and so we also study the surfaces and subsurfaces of other planets, moons, and asteroids around the solar system. And I do most of that using photographs and other types of data from robotic spacecraft that we've flung all around the solar system.
Wow.
But I also do laboratory experiments. So, to your question about the importance of water in the universe and the solar system, I mean, water is made out of hydrogen and oxygen, and hydrogen is the most common element in the universe. It was created in the Big Bang. And oxygen is also extremely common throughout the universe because it's created in most stars in the nuclear fusion process. So water is actually extremely common, but getting liquid water is particularly rare on Earth. Earth is the only place with liquid water at the surface, where the surface temperature and pressure are above freezing but below boiling. But there is also liquid water underneath icy shells in the outer solar system. So, probably a lot of your listeners may know that Jupiter's icy moons, especially Europa and Ganymede, are known to have underground liquid water oceans in contact with hot or at least warm rock. So you've got all the ingredients for life right there. You've got an
Wow.
energy source, the heat. You've got nutrients in the rocks, and you've got the solvent water that we know that all life on Earth needs, at least. And we know that Saturn's moon Enceladus also has a subsurface liquid water ocean. And when you go to the medium-sized moons of Uranus, for instance, Mimas, no, not Mimas, Miranda, Ariel, Umbriel, Titania, and Oberon. We've only imaged them once up close with the Voyager 2 spacecraft in 1986. Those small moons we think are frozen now, but we think at the beginning of the solar system, 4.5 billion years, that maybe for the first half billion years, those had liquid water oceans underneath their surfaces, and there could have been life. And if we go out to small planets like Pluto and Eris and these other small icy planets beyond Neptune, we likewise think that they either have or had liquid water oceans. And so liquid water underground, we think could actually be extremely common, not just in our own solar system, but indeed the whole galaxy and the universe.
Yes,
Uh,
so exciting. And I've never heard someone go through the moons that quickly. That was well done. Really,
Thank
really
you.
cool.
Thank you. I've been
So the
practicing.
challenge is getting to the water, right?
Sure, that's get the challenge. Yeah, getting to the water is certainly hard. In the case of Europa, we think it's tens of kilometers, tens of miles underneath the subsurface there. But with something like Saturn's moon Enceladus, it's a small moon. It's only about 500 kilometers across. There are literally asteroids like the asteroid Vesta that's bigger than the moon Enceladus, but it's got these geysers spewing
Yes.
water out of the South Pole. And
Yes.
so, and Europa does too, but Enceladus is doing it way more. And so actually getting to that water is relatively easy. All you have to do is send a robotic spacecraft 1 billion miles to Saturn and fly through the plumes of Enceladus, but to do it slowly enough so that you don't squish any bugs on your spacecraft's windshield, because then you've just killed what you want to sample. So,
Yes. Oh, that
um,
sounds simple.
yeah.
Just that.
So that's actually that kind of life-finding mission to Enceladus was the #2 rated large mission by the National Academies of Sciences.
Yeah, so this is a great question for you. I don't know how much you dabble in policy or doing, persuasive pitches to how we're going to fund these kind of
Hmm.
expeditions, but how does one decide? I mean, you have a vested interest because I'm sure even right now, as we return to the moon,
Yeah.
maybe you can help walk us through this. I just
Hmm.
heard that there are volcanoes on the moon
Oh,
where
sure.
there's
Yeah.
seismic activity happening, where there's some places we don't want to land, we want to steer clear from. And there's some places that are not as seismic. I feel silly that I didn't even know this. And so when we're considering, where we're going, there's all
Uh-huh.
these things that we have to think about the places we're going. And then how do you justify this needs to be looked at in a deeper sense and therefore gets higher priority, and then this one doesn't? How does that work?
Right. So the whole issue of who pays for it and how do you prioritize questions is definitely a big piece of policy. And the nonprofit Planetary Society is really good at that. My friend and sort of colleague Casey Dreyer does a really great job kind of getting into the guts of that. But
Yeah.
it starts with the democratic process and contacting your senator and congressperson and saying that you think that funding for NASA and particularly what's called the Science Mission Directorate is very important to you. But every 10 years, the National Academies of Sciences gets tasked by the government to prioritize, to talk to the planetary science community through white papers that people can submit. And then they write this very well written document laying out the current state of planetary exploration. And they also include prioritized lists of missions that they would recommend that NASA fly. Now, NASA's not legally bound to that, but it's a really good guiding document. But there's other countries in the world funding planetary exploration. The United
Mhm.
States doesn't have to go it alone. The Japanese space agency, JAXA, has a really good niche in exploring asteroids and small moons, as an example. And the European Space Agency is also doing a lot as well. But we're also getting into a time when the private sector is just now starting to dabble in science missions. There's a privately funded mission going to Venus in the next few years that's led by the launch company Rocket Lab in collaboration with MIT. And that is to go study the clouds of Venus in case the clouds of Venus could be habitable.
Oh
It's
my
not as crazy as
gosh.
it sounds, right? Yeah.
What?
Yeah, well, Venus, we think Venus had liquid water oceans on its surface up until relatively recently. And by recently, I mean about 1 billion years ago. So, all the
Pretty
planets,
recent.
all the moons are about the same age. They're all about 4.5 billion years old. So when Venus turned about 3.5 billion years old, its oceans probably started evaporating. And there was a runaway greenhouse effect. This is at the same time that the sun was also getting a little bit hotter and brighter in its energy output. And of course, there's no liquid water anywhere on the surface of Venus today. But it's not out of the question that life could have started on Venus. And then as the oceans were boiling away, could have evolved to be so small that they're just aerosols getting wafted in the breeze. And they could live out their entire life in the atmosphere, in the clouds.
Amazing.
So, and the upper atmosphere of Venus is very Earth-like in its temperature and pressure, and
Oh
so it's
my
possible.
gosh.
Hmm.
Oh my gosh. So privately funded, and
That's
then
right.
how do they ROI that? Do they produce the research? Are they looking to do
Well,
some kind of mining? I mean, what is the end goal?
yeah, well, that's a really great question for Rocket Lab. I think the ROI is philanthropy because I don't think it's right now the science doesn't have a direct payoff yet. But I think that's one reason why we have philanthropy on one hand and government-funded basic research on the others, because
Sure.
that kind of science can answer questions. They can find the answers to questions that we're not even smart enough to ask. So,
Exactly. I love
um,
I love those kinds of questions
yeah,
or
yeah,
answers before the questions, like discovering things that we didn't know to ask even exist. I love
right.
that.
Yeah, I mean, that's really why. I mean, yes, I'm a planetary geologist, but I'm a space nerd just before all of that. And I'm
I
just
love that.
curious. I just want to know.
Yes. Well, you're in the right place then and in
Great.
the right job. What
Yeah.
got you started? What was your interest and how did you find it?
Yeah, thanks. I don't know. I've been interested. I've been fascinated with space my entire life, at least since I was 3 years old. So that is much more than 30 years ago. And the only thing that I can really pinpoint was I was growing up in the post-Challenger Space Shuttle Challenger accident world, and I can only imagine that the shuttle program was on the news a lot. Maybe it was on the news on TV, and maybe my parents had it on, and I came across it. I went to a space. My parents took me to a space museum that's since been closed. I grew up in southern Michigan, not a huge space state, but there was a little museum called the Michigan Space and Science Center that's now closed, unfortunately.
Oh,
But I went there. There's pictures of me as a 3-year-old there, and maybe that helps spark it. But I've
thank
always
you,
intended to.
parents. Love
Thank you,
that.
mom and dad.
Yeah.
Um, but there were things along the way that stoked my interest, like getting a telescope for Christmas.
Oh,
Watching Star Trek, watching Star Wars, even though it's science fiction, it kind of helped keep the dream alive.
sure.
And just always pursued science throughout school, college, and graduate school. And I'm a NASA-funded planetary geology research scientist now for the Planetary Science Institute. Did my PhD at Johns Hopkins, and I also have a consulting company that specializes in space tourism and space entertainment.
Oh, tell
So
us more about that.
yeah, well, so I feel a little different from a lot of my scientist colleagues because I'm not content just as if that was a small thing. It's not to know about the universe. I want to experience the universe. I'd love to go to space. I've gotten to go on quite a number of zero gravity parabolic airplane flights with the Zero Gravity Corporation on their specially modified Boeing 727. And
Awesome.
weightlessness is a continual dream come true. Um, I've
Was it everything you
also
thought it would be? And did you get sick?
I did not get sick. Most people actually do just fine.
Oh, wow.
Yeah. It is everything I thought it'd be. I knew it would be something that's indescribable that you have to experience. And I was right about that. I think it was exactly what I wanted it to be, but I didn't know exactly what that
Awesome.
felt like, which is why I wanted to experience it the first time. I
Yeah.
remember the first time I really got weightless. It was on my very first parabola when the pilot starts pitching the nose of the airplane over. I just felt my weight just dissolve away. I just gently tapped on the floor, floated up to the ceiling. I spun around and I saw someone just fly underneath me between me and the floor. And my first reaction was be like, oh no, I'm gonna fall on her. But no, we're both weightless, we're not falling. And I was upside down at the ceiling, but felt just at home right up there on the ceiling. You don't feel upside down or right side up. But it's also such a strange experience that you just can't help but laugh a lot because your brain doesn't know what to do with that.
Oh,
Um,
I'm perfectly fitted for that then. I laugh all the time.
Beth, we got to get you
I'm
up on a zero G
qualified.
flight.
I'm
Yeah,
trying. Yeah,
yeah.
for sure.
But I've also been able to work with ticket holding future astronauts with Virgin Galactic.
Yeah.
And I've taken them out in tours in New Mexico to tour up close and personal the geologic landscapes that they're going to be flying over in space. Um,
That
a
is
lot of us
so
are
cool.
a lot of us are familiar with the overview effect, this
Yeah.
cognitive shift that happens when you see the Earth from space. And astronauts commonly like to talk about when they first see the Earth from space, they like to pick out areas that are familiar to them. And not a lot of people know about the geology of New Mexico, and that's understandable. The Virgin Galactic takes off out of Spaceport America in southern New Mexico, and New Mexico's got amazing geologic landforms,
Yeah.
not just for Earth, but they're also analogous to geologic landforms elsewhere around the solar system. So it's as if you can visit aspects of Mars or visit aspects of the moon or other places just by visiting these really cool geologic locations in New Mexico. And the idea was to give the private future astronauts an up close, in your face view of the rocks and the landscape, understand how this natural landscape came to be so that they can understand that landform up close and also understand it when they're in space. And they can understand the same thing from two vastly different perspectives and scales.
Brilliant.
And
So you
and
serve as their guide to kind of ground, if you will,
oh yeah,
literally,
that's a good way to
what they're
put it.
seeing and from a different perspective, from a different viewpoint, and why it can be relatable or studied or applied in the universe, in our solar system in a big way. Wow.
Yes, it's exactly. I've
And
tried to connect people to the cosmos through what they can experience on Earth.
and what
So,
do they say after? So you do this extensive like walkthrough and you kind of show
mhm.
them the formations and what it is and how it came to be. And when they come back, what do they say?
People seem really interested. I'm a rock nerd, so I'm a little biased maybe, but I give like a college level lecture. We'll get to a spot like a lava flow or a sand dune, and I'll give a little college level lecture, like intro class lecture over the geology, how it formed, um, what it looks like up close, what it looks like from space. I use pictures from Sir Richard Branson's first space flight a couple years ago to show you what the exact same thing looks like from space as what they're literally walking through. And people's faces are animated and they seem to really like it. One of my former clients, who then he's become a friend since then, Ken Bowden. We've been out there twice together now, and he just loves it. And another one, a person who's become a friend, Elizabeth Schneider. She just loved the learning about the geology that she's going to see from space.
Oh my
So, but
gosh.
it's not just for ticket holding private astronauts either. It's anyone who wants to learn about how New Mexico's geologic landscape relates to space exploration.
I do. Yes.
Great.
How can people from who are listening, can they take this as a course or come see you? How does it work?
They can, yes, through my space tourism consulting company,
Yeah.
Planex,
Okay.
and the website is planex.space, Planex.space. People can sign up to go on trips with me that I guide in New Mexico.
Oh my
And
gosh.
so I'd encourage any of your listeners who are interested in experiencing the planets of the solar system and what Earth is like from space in New Mexico to contact me via my website.
Oh, that
And
sounds
I'm already
amazing.
leading a trip this coming October, and with enough interest, we can lead more trips.
Okay, I'll be there. Oh, I'm
Great.
sorry, I didn't get invited yet.
You're
I'm
invited. Everyone's
coming.
invited.
I'm gonna put it down for my birthday wish list in
Okay,
November. Go and come on
great.
out in October. No, there's so much to learn. And I think people, I know I love when I get to learn and it comes not from a book, but from the real, tangible field experience. I can take that and much more easily translate that into, oh, if we have lava tubes in
Mhm,
Hawaii and we'll have lava tubes on Mars that we think will protect us from radiation and keep
mhm,
us maybe a little more safer or be able to perhaps grow and build and design habitats within the lava tubes. Now that I'm here touching, feeling, smelling, sensing,
yeah,
I get it. And up until an analog expedition, I had no
right.
idea that lava tubes were even something that existed in space or
Mhm.
could be used in space. So what you're doing, Kirby, phenomenal. I love that.
Oh, thank you.
When are you going? And also when you go, if you had the chance, I
Uh-huh.
can only imagine as a geologist the vast number of places on your wish list, but where would you really like to explore in person?
On Earth or off Earth?
Oh gosh, great. That's a great rhetorical question and feedback. Both I didn't mean rhetorical. I mean, that was a great question. Let's say both.
Okay, on Earth, I'd love to go back to Iceland and Volcanoes National Park in Hawaii and see some
Oh,
more volcanoes erupting up close. I'd like to go to Camille Crater in Egypt. It's like literally like a mile or so north of the Sudan border, but it's a very small impact crater that was only discovered by someone exploring in Google Earth from Earth orbital imagery. And it's a fairly young, fresh impact crater on Earth. Earth has actually more impact craters than the planet Venus on its surface.
wow.
Um, and so those are a few places on Earth I'd like to go to that are related to planetary features. I would love to go to the moon. And if I could do the whole trip in 2 years or less, I would go to Mars also.
Yeah, wouldn't we all? Yeah,
Yeah.
2 years or less. Sometimes I the Johnson Space Center just currently put out the announcement, or is it the job opportunity for those analog astronauts to apply for
Okay.
the 1 year analog?
Oh,
And
wow.
I think to myself, gosh, a year is a really long time, but 2 years is really long. But it's only a fraction of what it's going to take for us to, travel to other planets. So,
Right.
I guess in the grand scheme of things, what's 2 years?
Yeah.
Um,
Well,
Dr. Kirby, something I didn't realize. I think I knew from my academic studies, but I didn't realize that I'd love to ask you about.
mhm.
The Earth has gone through not just one, not just two, but several major catastrophes where it has completely reinvented, reinvolved, reestablished itself.
Yeah.
And we all know the famous one with the astronaut, with the asteroid and the dinosaurs and how it wiped them out. But the Earth has been rejuvenating over and over again several times.
That's
Why
right.
are we so surprised by this? And it's really a miracle that the flora and fauna and bacterial beings that have come to place have existed.
Right. Yeah. Well, complex multicellular life on Earth has existed for only about a half a billion years. I know that sounds like a long time, but think about for the Earth's first 4 billion years, there really wasn't any, there was life, but there wasn't complex life. And in the last 500 or 700 million years, since there's been complex life, there have been lots of mass extinction events. A lot of times it's related to massive volcanic eruptions that we have absolutely no touchstone of familiarity with. Um, there's a huge lava flow in northern Russia and Siberia called the Siberian Traps. There's even a place in New Jersey, right along the turnpike across the Hudson River from New York City, where there was massive lava outpourings, and
No way.
nothing like that has happened any time recently. But those kinds of eruptions put out so much carbon dioxide and sulfur dioxide that lead to massive and even catastrophic naturally occurring climate change. And I think we act surprised because our lifespans and our memories are so short relative to the pulse of the planet, if you will. So yeah, there's 55,000 years ago there was a metal asteroid impacted in Arizona and formed what is now Barringer Meteor Crater. You can pay $20 admission and go there right now and go see it. Um, but that set off the equivalent of a nuclear bomb in northern Arizona when it happened.
Wow.
And that was only 55,000 years ago. I mean, humans were around for that.
Gosh.
But it wasn't, during recorded history.
Yeah.
So I think our short lifespans and our forgetfulness contribute to us not realizing that there have been multiple times where there have been catastrophic volcanoes and catastrophic asteroid impacts on Earth
Yeah.
that have disrupted the climate.
Gosh, there's so much to learn, and we just can't do it all in one conversation. I know you're super busy and you've given us so much of your time today, but we'd love to have you back on the show where we're just talking about, where we're going to land on Mars. Are you mapping? Did I understand? Are you helping to map the surface of, I'm sorry, the moon?
That's right. Yeah. So
Oh my gosh.
I have a NASA grant that's allowing me to do some detailed geologic mapping on the moon. And you had asked earlier in the conversation about volcanoes on the moon. And when you look up at the moon at night and you see the light areas and the dark areas, first of all, I'm always a big advocate for people just taking a pair of binoculars and looking at the moon. And that's a really easy threshold to get over because if you don't have a telescope, you can still ask your friend to borrow their binoculars.
Yeah.
And even a pair of bird watching binoculars will help you see the moon and more. You can start seeing craters and things. But all the darker areas you see on the moon are actually cooled lava flows, all of them. And it's the same general type of lava as in Hawaii or Iceland. It's a volcanic rock called basalt. It's the most common rock on the surface of planets in the whole solar system. And in some of my geologic mapping, we see areas where you see these really oval-shaped vents, lava vents. You see dark areas where the nerdy term is pyroclastic deposits,
Okay.
fire rocks, where they've landed around the volcanic vents.
Oh
And you
yeah.
can see if you've ever seen a lava flow in Hawaii or Iceland, or even in the American Southwest from old lava flows, you can see how they kind of have like this lobe-shaped, jagged outline. And you see the exact same type of we would call it a morphology, that shape on the moon and actually on Mars and Venus and other places as well. So the moon was volcanically active up until about 1.5 or 2 billion years ago. Um, as a geologist, I like to think of the moon as a small planet, and it's a small planet orbiting a big planet. And because the moon is smaller than Earth, it lost its heat faster because its surface area is quite large
Mm.
compared to its volume. And so the moon cooled off, so there's not as much volcanic activity on the moon as there is on Earth. But there's still quote unquote young lava that's only 2 billion years old on the moon, and you can see these lava flows. And so that's one of the things that I've been mapping on the moon.
Oh my
The
gosh.
reason I'm doing that is to try to find future landing sites for either future robotic missions or maybe even astronaut-led missions, like in the Artemis program.
Yeah.
Uh, because picking up rocks on the moon is not enough. You got to pick up the right rocks to answer the right geologic questions. And um, I'm interested in finding the rocks on the moon that record the impact history, how the moon was getting the tar beat out of it by asteroid and comet impacts around 4 billion years ago, because that impact record is basically the same as Earth's early impact record. Earth was getting hit just the same amount. We're bigger and we have stronger gravity, so actually a little bit more than the moon. But Earth doesn't have that geologic record anymore. Our plate tectonics, our water, our life have erased that geologic record of when we were getting the
Yeah.
tar beat out of us 4 billion years ago. But that's also the same time in Earth's history that the very first chemistry was evolving into biochemistry, when life was somehow emerging from non-life, which we still don't know how that works. There's some hypotheses out there, like the RNA world hypothesis. Um, and so understanding the environment on early Earth is part of answering the question of how life starts on Earth in the first place, which will help us also understand how life could have started on places like Mars or Europa or Enceladus or elsewhere. So
Oh my
that's a
gosh.
little snapshot of some of the NASA funded research I've been working on
That's
lately.
incredible work, Kirby. I
Thank
can't
you.
believe it. That's phenomenal. Do you ever feel pressure? Do you feel like when you're finding and doing this research that you're like, wow, there's a lot of weight? Or do you let the science speak for you when you find the research and data? Or,
Yeah, I guess I let the science speak for me. I love, I'm a very visual person, so I love looking at, so this is literally drawing lines on pictures of the moon. Um, and so I just love staring at the moon all day, deciphering its geology. Geology is a forensic science.
mm,
Something happened in the past to make the landscape that we see, and it's the job of a geologist to reconstruct the past uh, based on the clues that are there, just like an investigator might approach a crime scene to try to reconstruct the events of
I
the
love
crime.
that example. That what a
So
wonderful description.
yeah.
What is something that people usually get wrong when it comes to something in the universe or something in geology outside of our Earth's
Uh-huh.
um, references that you
Yeah.
always are clearing up for folks and helping us understand better?
Well, one of the things is, yes, the moon really did have volcanoes. That comes up a lot, actually. People are surprised at that. The moon
I
does and
was
did have
certainly,
volcanoes.
yeah.
Yeah, yeah. Another one is the gravity level on the moon. It's 1/6 the gravity of Earth. It's not so low that things just float off into space, but it's low enough that if you're an astronaut operating on the moon, you have to work a little bit differently. And I'll also plug the Zero Gravity Corporation again, because on some of their, well, on all of their parabolic flights, they start off with doing moon gravity parabolas so that you can literally bunny hop or moon hop like an astronaut, and you can feel how incredibly low moon gravity is and how that changes how you have to operate. Other things that I tend to clear up with people have to do with water ice, just frozen water on the moon. Um, we actually don't know, we know it's there, but we don't know what state it's in. We don't know if it's giant slabs of ice or if it's like a snow cone with like little granules of ice mixed in with the
Ah,
dirt, what we call regolith,
mhm.
or if it's rocky grains that have like a thin ice coating. We don't know. And since we don't know, we got to go and find out. And actually, that's one of the objectives of the Artemis 3 mission, with astronauts going back to the moon for the first time since 1972, is to start to understand the distribution and the nature of ice. And so before we can make mining equipment to go mine out that frozen water, we have to understand what it's like. You can't design something where you don't know what it's going to be scooping out.
Ah,
Um, so And eventually we'll be harvesting ice on the moon for the hydrogen and the oxygen, the rocket fuel, but also as life
Yes.
support for crew. For
Yeah.
and
See, this is why we have to have you back on the show because there's so much more to talk about on how that would work and why NASA clearly needs to send you.
well, thank you. Yes, I'd love to be back on the show, and I'd love to go to the moon.
Yes, I would love that. Thank you for your time today. And then I want to show everyone and showcase where they can find you because I just know that there's going to be more questions.
Mhm.
And I know there's so many listeners would love to get a hold of you, whether it's to go and explore in October with you or
Mhm.
in general. So where can they find you?
Yeah, they can find me at my website, planex.space, Planex.space. And my email address is on there, Kirby@planex.space. And I'd love to get in touch with your listeners.
Yes, we would love that. That sounds like a great plan. And please do come back on the show soon. How about if nothing else, if the whole, summer escapes us and everything else, can you come back and tell us about post October's trip and the folks you've taken out there and what you've all learned and how the experience went? I'd love to hear
Absolutely.
that.
Yeah. Thank you.
Okay, good.
I'd love to do that.
Yeah, that sounds great. Well, whatever you're doing today at your alma mater, I hope it
Uh-huh.
is successful. I can't wait to field some of those questions with you. So I'd love to hear when people do get a hold of you. Let me know what they ask.
Sure
And
thing.
come join us again because there's so much more to learn. You have been so informative and educational. I've learned a lot in just our brief time together. So please do join us again.
Thank you. I will, Beth.
All right. Thank you.